And welcome to the final episode dedicated to my test based on a natural oak veneer panel. But overall, I actually want to first bring you up to speed on what veneer even is. Veneer itself is a thin slice of wood. You see how thin this sheet is, right? Right now, specifically, this is birch. And this is the wool idea. You take a base, you take veneer, and you apply it to the base using glue. Then it's processed in different ways. It can be impregnations, toning, it can be lacquer, and so on. But the main point is there is a huge variety. There is no specific intended use from the manufacturer for this material, because veneer itself is a separate product that can be used in many different ways. And separately you have the base, it can be chipboard, it can be MDF. And depending on how all of this is treated, what it's impregnated with and how it's protected, you end up with completely different variations of these panels. Honestly, I'll say it like this: veneer is a wool separated world. Panels with veneer, that's a completely separated world. There are so many parameters, types of wood, application methods, processing methods, that my specific test scenario is not a final reference point for making decisions. My goal is to start a line of thinking and explain what this material actually is, and that you need to approach choosing it very conscientiously and look for reliable, proven manufacturers. Alright, let's talk about manufacturing and processing. You already heard there is a base, chipboard or MDF. Then there are different types of veneer. There is natural veneer, like this one. Its feature is that wood is not uniform. Different tree trunks have different shades. So you need to select the trunk, select sheets from it, and it's very important that these sheets are not over-dried. Then all of this needs to be assembled into a pattern, because veneer also has different matching styles. Mirror match, book match, and all sorts of mixed pattern like this one, where different sheets are combined. And depending on that you get completely different visual results. Maybe you've seen patterns like diamond layouts. There is a huge variety. I won't even list everything. So, natural veneer, you take a base, glue veneer onto it, process it with oils, toners or lacquer, and that's already a big separate workflow. Then there are pre-finished veneers from manufacturers. For example, Italian TABU veneer. They take wood and process the veneer layer in advance, apply toning, brushing, and so on. In this case, the veneer doesn't need further processing, it already comes in its final color. But even then, it still comes as a thin sheet like this. And the facade manufacturer still needs to choose a base, make a layout, glue the veneer. So the technology is still the same. Only the coloring is already done. Then there are engineered veneers like fine line. For example, the samples here. This is a completely different story. Take zebra wood, for example, it exists as a natural species, but it's very expensive. Fine line veneer is reconstructed veneer. The most common material used is fast growing poplar, also ios, abashi, sometimes linden. The manufacturer cuts it into thin elements, tones each one separately, then assembles them to artificially recreate the pattern of specific wood. So here I have zebra wood, ebony. But this is artificially created, not real wood species. The advantage here is that the manufacturer can ensure much better consistency in pattern and color between sheets. But again, it still comes as sheets, and you still need to glue it onto a base to get a finished product. Another interesting point: edge bending. On veneered panels, the edge is made from the same veneer as the front surface. Because there is no factory edge bending with the fixed parameters, you can take different MDF thicknesses, glue them together and apply thick veneer edges. For example, if you want a solid looking 100 mm thick countertop in veneer, you can do that. Now about milling. You already understand what milling is from the previous episode. I intentionally use this painted facade as an example. It's the most classic and popular milling profile. There are flat sections and shaped sections with radiuses. Now here's the key point. Veneer does not stretch. Paint can cover these shapes because it's sprayed, but veneer can only be applied to flat surfaces. So only flat parts, edges and steps will be veneered. The inner curved areas will not. And maybe you've seen this in real life, a veneered facade where the outer areas have wood texture, but the center looks painted. That's because inside there is MDF painted to match the veneer color, and no wood texture is there. Technically it's possible, but extremely complex and expensive, so nobody does it. So milling is possible, but it becomes a very specific product. There is no universal answer. Decorative possibilities. If it's natural veneer, it's wood texture. The main design tool is how you lay out the veneer sheets. Color depends on the original wood. For example, if you take dark American oak and try to bleach it into white ash, you can do it chemically, but it doesn't make sense. You need to consult the manufacturer about how a specific wood behaves and what can be done with it. So decorative results are almost always unique, because many factors come together. Now let's move to conclusions, but first a quick story. In the previous episode about painted facades, I talked about how many processes affect quality. I remembered a case from 6-7 years ago. I made a kitchen and another team made a wardrobe. The client asked me why their paint cracked. I looked at it, flat surface, but cracks along the perimeter. Turns out they used chipboard, applied 2 mm edge bending, and painted everything. Different materials expand differently with temperature, and the joint cracked. All facades cracked along the edges. Now conclusions for this specific sample. Natural oak veneer on MDF, finished with acrylic oil. Stain resistance. Overall decent. A lot of was cleaned off. But there are nuances with marker and cleaning, check the stain episode. Scratch and impact resistance. Lower than chipboard, comparable to painted MDF. But veneer has an advantage. Scratches can be easily hidden with simple household methods like wax sticks. Moisture resistance, not great. Check the fire and water episode. Safe zones, wardrobes, shelves, walk-in closets, living rooms, bedside tables, dressers, TV units. Minimal loads works fine. Kids' rooms. Problems with stains, scratches, impacts. Not recommended. Bathrooms, laundry. Moisture plus stains. Not recommended. Hallways. Scratches and impacts. Weak performance. Work surfaces. Desks, taps, cancels. Weekend stains plus scratches plus impacts. Better use solid wood instead. Because veneer is thin once damaged, the base is exposed and the delamination begins. Solid wood can be sanded and restored. Kitchens. Facades possible with conditions. Clean stains immediately, no long exposure. Otherwise not recommended. Impact. All materials behaved similarly, base matters more. Scratches. Same as matte paint, but easier to hide. Steam. Handled well up to 100 degrees. Countertops. Absolutely not suitable, just forget it. Outdoor use. Stains won't clean, weak moisture resistance. Only possible with full sealing, plus lacquer, and even then, limited lifespan. Final recommendation. Safe zones. Recommended. Specific zones. Not recommended. Functional surfaces. Not recommended. Kitchen. With strict limitations. That's it. Thanks for watching. See you in the next videos.